Hello guys, you're welcome to class. Today you are going to learn the interior and exterior angle of a polygon, how to calculate the sum of angles in a polygon, and lastly, how to calculate the number of sides of a polygon. See you at the end of the class. It is a beautiful day. Look around. Whether you're in your house, in the street, or in the shopping mall, you see different kind of shapes. But today, we are going to explore special shapes. These are some of the real world facts about polygons. Now, what is a polygon? A polygon is a two-dimensional closed figure formed by joining the endpoints of at least 3 line segments. Now, according to these definitions, let's see some of these shapes, whether they are polygon or not. Oh, this is a polygon. This is not a polygon. This is a polygon. This is definitely not a polygon. This is a polygon. No, not a polygon. Let's look at names of polygons according to the number of sides. A triangle has 3 sides. Quadrilateral, 4 sides. A pentagon, 5 sides. Hexagon, this has 6 sides. Heptagon, this has 7 sides. Octagon, this has 8 sides. Nonagon, this has 9 sides. Decagon, this has 10 sides. We have all the types. You can always pause this video and go through them. Depending on the number of sides, polygons are numerous. Let's look at some real-life examples of polygons. A triangular shape, rectangular pool, pentagonal field, the beehive, a trash bin, a clock, even your ceiling, a starfish. Amazing, right? So, whatever you do, whether you're busy doing your hobby, creating or doing something, polygons make everything stunning. From tall buildings, look at tall buildings, to these spectacular roofs. It makes everything organized. Take a look at this estate. Always remember that polygons are everywhere. Hope you enjoyed this little introduction. Interior and exterior angles. We are going to be looking at interior and exterior angles of polygons. Interior angles. The interior angles of a triangle add up to 180 degrees. Remember that in a square we can fit in two triangles. This gives us 180 degrees by 2, which will give us 360 degrees. Next we have an irregular pentagon. We can fit 3 triangles. The interior angles will be 180 by 3, which will give us 540 degrees. Next, we have an hexagon. We can fit 4 triangles, which will give us an interior angle of 180 by 4, which is 720 degrees. Notice anything? The number of triangles equals the number of sides minus 2. Also, the sum of interior angles equals n minus 2 multiplied by 180 degrees, where n is the number of sides. Let's look at this example. The sum of interior angle is the n minus 2 multiplied by 180 degrees. Since it has 5 sides, then the interior angle will be 540 degrees. Each interior angle then can be calculated by dividing 540 by the number of angles, which is 5. Let's move to exterior angles. The sum of exterior angles add up to 360 degrees. Also, exterior angle equals 180 degrees minus interior angles. Remember the angle on a straight line. Number of sides equals 360 degrees divided by the exterior angle for regular polygons only. Now, what is the exterior angle of a regular hexagon? What is the interior angle of a regular pentagon? And lastly, how many sides does a regular pentagon with exterior angle of 30 degrees have? Now we have the answers. You can pause this video to have a clearer view. I want you to listen to this research on why honeybees uses an hexagon in storing their honey.
Honeybees are fascinating creatures for a number of reasons. Their incredible work ethic, the sugary sweet syrup they produce, and their intricate social structure. But another reason is that honeybees are, in fact, excellent mathematicians. Scientists claim that tiny insects can calculate angles and can even comprehend the roundness of the earth. But there's particular mathematical bee genius behind the most important aspect of honeybee life, the hive. Just like humans, bees need food and shelter to stay alive. The hive is not only the bees' home, but doubles as a place to store their honey. Since it's so central to survival, honeybees have to perfect the hive's architectural design. If you examine any piece of honeycomb, you'll see that it's constructed from tightly packed hexagonal or six-sided cells. Of all the possible designs, why do honeybees choose this one? To understand, you need to think like a bee. Bees need a secure place for their entire colony to live. Similarly, there needs to be a place where their nectar can be stored and ripened suitably, until it turns into honey. That means there's a need for some serious space efficiency. A good solution is to build little storage units or cells just big enough for a bee to fit into, which can also double as the containers in which nectar is stored, the bee's very own honey jars. The next thing is to decide what the little cells should be made out of. Bees don't have beaks or arms to pick up things, but they are capable of producing wax. The thing is, producing it is a lot of hard work. Bees have to consume 8 ounces of honey to produce just 1 ounce of wax, so they don't want to waste it. So they need a design that allows them to store the largest possible amount of honey using the least amount of wax. What shape does that? Imagining for a minute that all bees had to attend Architecture Academy and go to math class. Let's say they asked their geometry teacher, what shape would give us the most space to store our honey but require the least amount of wax? And the geometry teacher replied, the shape that you're seeking is the circle, leaving the bees to return to their trial construction site and begin building their honeycomb using circular cells. After a while, some of them might have noticed a problem with their design. Small gaps between the cells. We can't even fit in there. That's wasted space, they might have thought. So, ignoring the geometry lesson and taking matters into their own hands, the bees went back to the drawing board to rethink their beehive design. One suggested triangles. We can use triangles, look, they fit together perfectly. Another bee suggested squares. Finally, a third bee piped up and said, pentagons don't seem to work, but hexagons do. We want the one that will use the least amount of wax and be able to store the most amount of honey. Yes, I think that's the hexagon. Why? It looks more like the circle than the others. But how do we know for sure? To find out, the industrious insect architects calculated the areas of the triangle, the square, and the hexagon and found that the hexagon was, in fact, the shape that gave them the most storage space. They agreed on an ideal size and returned to work. The space-efficient comb that is a bee's trademark today is probably the result of this trial and error, but over long periods of evolutionary history. However, it paid off. Peek into any hive, with your protective goggles and netting on, of course, and you'll see the end result, a beautiful, compact honeycomb that any architect would have been proud to design.
A brief recap. You are welcome back. I hope you have learned a lot in this lesson. If you have any further questions, you can drop it in the comment box. See you in our next lesson.